Hello, it's Jim from JetsonX.com. Today we're taking a look at the brand new $399 NVIDIA Jetson Xavier NX Developer Kit. NVIDIA sent over a Jetson Xavier NX Developer Kit for us to play with. Let's see, 2 pieces of tape, 1 on each side. Let's open up the box. That looks pretty promising. Let's pull the flap up. We have the power supply. This one's not for sale, but you could buy one from the link in the description below. 19 volts. Oh, and it's a 45 water. Let's put that aside. And we have the power cable for the power supply, of course. And then we have our board. I wonder how you get it out of here. I'll yank here. There we go. And the board should slide right out. Hooray. Here's a little card. And the instructions. Quick Start Support Guide. Anything else? Nope. Good to go, G. Let's put our boxes away. Flip it over. Attention. Observe precautions. Oh, we'd better ground ourselves. Okay. We'll lift up the tape. Come out of there, you little pig dog. Ooh. Well, that's interesting. At first glance, it's slightly different than a Jetson Nano. The carrier board is mounted on a plastic base. All of the connectors look about the same. 40-pin GPIO header, PWM. Oh, I don't see a PoE header on here. Power over Ethernet. 2 CSI camera connectors. Same connector layout as the Jetson Nano. The power jack is 19 volts. There's a fan integrated into the heatsink. I like that. This only runs off 19 volts, so we don't need a power jumper. Let's flip it over. Here's an M2 Key E connector with a wireless card installed. It looks like it's a standard wireless card from a laptop. And here are 2 antennas for the Wi-Fi card that are captured by the plastic base. And that's pretty cool. And here's the M2 Key M slot, full size. This is nice to have. You can run something like a NVMe SSD in it. Those are the immediately obvious things. There are 2 screws that hold in the Jetson Xavier NX module and the familiar capture clips. Let's take out the module, see what's underneath. I removed the screws, release the capture clips. We can see the 12-pin button header. Here's the module itself. It's pretty small. The heatsink has fins on it. It's a nicer thermal solution than the Jetson Nano. And here's the PWM cable that goes into the carrier board to control the fan. All in all, I say a good first impression. The Jetson Xavier NX Developer Kit has two parts. The first part is the Jetson module, which holds the compute elements and memory, and the other part is the carrier board, which provides I/O connectors for the system. Let's discuss the Jetson module first. Here's a picture of the Jetson Xavier NX module. The heatsink with the integrated fan has been removed. This is generically called a System on Module, or SOM for short. The Jetson Xavier NX module is available in two flavors. The first is the development kit version, which we are looking at today. The other is what is called a production module. The two versions are slightly different. The dev kit version uses a micro SD card for secondary storage. The production module has onboard eMMC memory instead. Also, the production module has a thermal plate instead of the integrated heatsink with fan. People use the Jetson production model to create new products. On the Jetson NX module sits an Xavier Tegra system on a chip, or SoC. The idea behind a SoC is that by adding some external memory and some simple glue chips, you end up with a complete working computer. By integrating all of the compute functions into one chip, you get much better performance and energy efficiency. Bottom line, need compute? Just pop in a Jetson module. The Jetson Xavier NX module has a 260-pin SODIMM connector, which mates with the Jetson carrier board. The module measures 45 millimeters by 69.6 millimeters. Tech spec time. Here are some highlights of the Xavier NX. We have a 6-core, 64-bit NVIDIA Carmel ARM version 8.2 CPU. There are 6 megabytes of L2 and 4 megabytes of L3 cache. The GPU is NVIDIA Volta architecture. There are 384 CUDA cores and 48 Tensor cores. There are 8 gigabytes of 128-bit low-power DDR4X memory, and the memory throughput is 51.2 gigabytes per second. The Xavier NX runs in two power profiles, 10-watt and 15-watt modes. In 15-watt mode, you get AI performance of 21 TOPS using int8. For speeding up inferencing, there are two NVIDIA Deep Learning Accelerator engines. There is a vision accelerator with a 7-way VLIW vision processor. The expected hardware video encoders and decoders are present, along with a Cortex M5 sensor processing engine. We'll talk about some of the low and high-speed communication channels that the Jetson NX provides when we talk about the carrier board. Flipping the board over, we have the underside of our dev kit module. You can see our micro SD card reader and the memory chips bottom and top. The cross brace in the middle holds on the thermal solution. Let's take a tour of the carrier board. This is the top side of the board. The Xavier NX module has been removed. Up here we have two MIPI CSI2 DeFi camera connectors. These connectors will allow you to work with Raspberry Pi version 2 cameras right out of the box. On the right side here, we have a 12-pin button header. This brings out system power, reset, UART console, and force recovery related signals. Notice here that we have an unpopulated area of the board, which appears to be ready for installation of a CAN bus header. Down here we have a 40-pin GPIO expansion header in a Raspberry Pi layout. One thing that is different here is that there is no power over Ethernet or PoE connector like the Raspberry Pi has. Finally, on the left side, we have the main external connectors, top to bottom. 19-volt power input, HDMI and DisplayPort connectors, 4 USB 3.1 connectors, Gigabit Ethernet, and a USB 2.0 micro B connector. Let's look at these connectors from a different angle. The display connectors are stacked, display port on the top, HDMI on the bottom. There are 2 stacks of USB 3.1 connectors, 4 altogether. Here are the 4 screws that attach the carrier board to the plastic base. The board measures 103 millimeters by 90.5 millimeters by 31 millimeters. The development kit weighs about 176 grams. Both of these are with the Jetson module attached. Let's flip the carrier board over. Here is a M2 key E slot populated with a wireless card. This appears to be a standard laptop type of device. The wireless card comes pre-installed on the kit. Notice that the antennas for the card are captured in the plastic base. There is also a full-size M2 key M slot, which is useful for adding extra storage, like a NVMe SSD. Let's talk about the Jetson software. We have our usual friends, Jetpack 4.4, CUDNN, TensorRT, DeepStream, and the Isaac SDK. These software libraries are the backbone, which makes the Jetson a platform accelerator to speed up most, if not all, tasks in an AI pipeline. Here's the Jetpack SDK page. This is where you go to set up your Xavier NX for the first time. NVIDIA provides many resources for learning AI on the Jetsons. Hello AI World is a great introduction to AI on the Jetson platform. 2 Days to a Demo is a series of deep learning tutorials to deploy AI and computer vision to Jetsons in the field. Jetson Zoo contains instructions for installing various open source add-on packages and frameworks like TensorFlow, PyTorch, MXNet, and Keras on Jetson. And Deep Learning ROS Nodes helps developers integrate AI capabilities developed with NVIDIA's AI tutorials with Robot Operating System, ROS. The next big push on the Jetsons is cloud-native containers. Powered by NVIDIA Jetpack SDK, Jetson employs the same NVIDIA CUDA-X accelerated computing stack and NVIDIA container runtime used in data centers and workstations around the world. I just read you a marketing blurb. Those are funny. The basic idea here is that NVIDIA has set up a server called NGC to distribute containers. Because NVIDIA tools are all cross-platform, applications can be created with the latest NVIDIA tools and optimized directly on a Jetson developer kit, a PC/workstation with cross-compile toolchain, or even in the cloud using cross-compilation containers. Enough talk. Let's start this puppy up. Okay, let's wire this baby up. I want to share with you a couple of pro tips. The first tip is to use a high-quality SD card. I use a Samsung Evo. I've had good luck with those. Don't waste your time buying the minimum required size. You want to make sure that you have enough room for development. Pros don't do the minimum required. They go large. The SD card reader, as you recall, is on the underside of the Jetson module. It's here. Let's insert the card. The pin side goes up. Press it in. You should be able to feel it seat and hear a little click. You're pressing against a little spring. The next pro tip is to get out your label maker. I have mine right here. You want to label your power supply, especially if you have more than one Jetson. And if you're like me, you can put on the label slightly crooked so it can trigger your OCD every time you look at it. The third tip is to put some electrical tape on the plug and the jack. For the nanos I use green, for this one I'm using white. It makes it easier to tell which plug goes where. If you use black electrical tape, I think you've missed the point. We will plug this in a moment. Let's plug in our keyboard. Let's plug in our mouse. And our HDMI cable. We'll connect that to our monitor. We are running the demo off of a Western Digital WD Black high-performance NVMe SSD. 250 GBs! You know we love our GBs. I will leave a link in the description below. The moment of truth. Let's plug this puppy in. We should see a green light go on. There it is! Let's switch over to our screencast. It's demo time! The Xavier NX is all booted up. This is the familiar Jetson home screen. I've been using the Xavier NX for a little while now. It feels very much like a laptop or a desktop in its performance. We can mix and match how many cores we are using. This helps us define performance in each one of the power envelopes we use. NVIDIA sent over a demo for us to explore. It shows off the power of the Xavier NX. Everything in the demo is running from containers. It takes a couple minutes to set up. Be right back. Okay, the demo is started up. Wow, the fan's just cranking. There are 7 models running simultaneously. Man, a Jetson Nano or a TX2 would just choke and die on this. Impressive. In the top left corner, we have the people detection container. This is running a containerized people detection inferencing task using DeepStream. It's analyzing 4 concurrent 1080p video streams to identify the number of people in each stream. This is a ResNet 18 model. Input image size is 960 by 544 by 3. And the model was converted from TensorFlow to TensorRT to run on the Jetson. In the bottom left corner, we have pose estimation. The container is running a neural network to estimate the pose of the people in the input video stream. You can see where it tries to model where their shoulders, their hips, legs, arms, and face are. This neural network is a ResNet 18 model with input image resolution of 224 by 224. The model was converted from PyTorch to TensorRT. In the bottom right corner, we have a gaze estimation container. You can see that when the subject looks directly at the camera, the boxes around the person's eyes turn green. You might use this as a cue to interact with the person. I would probably use it to determine if they were shifty. In the top right corner, we have a natural language processing demo. We call these an NLP. This is running the BERT NLP neural network. It's pretty demanding, is my understanding. It basically takes questions through voice input and provides relevant answers based on the passage that it's associated with. This demo uses 2 models, QuartzNet 15x5 for speech recognition that is converted from PyTorch to TensorRT. And then we have the BERT-based model for language model to NLP, which was converted from TensorFlow to TensorRT. Let's do a BERT demo. Let's try to make sense of what it knows about BERT. What is BERT? It's a deep neural network, 31.4%. What does BERT mean? Bidirectional encoder representations from transformers, 59.1%. What can BERT do? It can perform a variety of NLP tasks. It seems pretty happy with itself. How does BERT work? It got birth instead of BERT. This isn't as sophisticated as Siri or Alexa or Google, but it's certainly the beginning and it all runs on device. What is GTC? It's the GPU Technology Conference. Let's see, Jetson Xavier. What is Jetson Xavier? It is itself. How many cores does a Jetson Xavier have? $399. How many CPU cores? So it's a little bit off on that. But more importantly, let's talk about football. When did the NFL season begin? September 5th, 94%. Who won the Super Bowl? Kansas City Chiefs. Where did they play the Super Bowl? Hard Rock Stadium. Who are the Raiders? Kansas City Chiefs. Oh, we better fix that. There'll be riots in the street. Let's edit this. Where do the Raiders play? In Las Vegas. Much better. Where were the Raiders? Oakland and Los Angeles. Who are the San Francisco 49ers? Kansas City Chiefs. I knew it. Those people are all the same. If you like this video, give it a thumbs up. And if you have not already, please subscribe. Thanks for watching. Oh, and we were supposed to say, stay safe.